Today we are looking at additional mathematics, chapter 1, functions. So let's quickly take a look at the symbol for functions. For functions, we normally write f of x, right? We normally represent a function with f of x to signal what we are trying to depict. We say f of x for a function, to represent a function. And this f of x is same as y, is always equal to y. F of x is always same as y. Is that okay? So this is what we call function, and this f of x is y. Okay? So y, remember, is the vertical values, the vertical values on the graph, on the plane of geometry. Now let's take a look at quickly the first part, which is 1.1, which is the mapping of functions. Value of x, if you trace it to the line graph, you get a corresponding one value of y. You get a corresponding one value of y. For a single value of x you choose, you get a corresponding one value of y. So for the one output value. So this is called one-on-one function. Then for quadratic graph, we have many-to-one function. We call it many-to-one function. So see, you have this. You have two values touching this graph here. At this point, if you touch this place, trace it down to the x-axis. That's one value of x. You can call here x1. One value of x. You can call it x1. And then if you trace this point on the graph to the x-axis here, you can call it x2. So you can see we have many, not one. We have many input value. Remember, the x values and the input value. Now if you trace them to the y value, you get only one y value here at this point. You get only one y. Trace to many values. Here are some functions. The symbol for function, apart from writing f of x, it can also be written as x definition of function, other section 1.2. So when do we know that a given mathematical expression is a function or is not a function? Now, a function is only a given expression, mathematical expression or algebraic expression is only a function when it's one-to-one, okay, or many-to-one. So only other two scenarios, one-to-one or many-to-one. That's when we call it a function. But when it's one-to-many, it's not a function. So functions are relations to the f and y variable. If there is a linear relationship which is one-to-one, meaning for every one single value of x, you get a corresponding value of y, such is a linear function, which is called one-to-one function. And for quadratic, for two or more values of x, you get a corresponding one value of y is also a function. So, and that is called many-to-one type of function. Now, in function, there are some languages we need to get used to. The first one is called the domain. The first language we need to get used to is the domain. The domains are the sets of values of the sets of value for a function. Okay, the sets of input value, the values that you input into the machine, into the mapping. Okay, so the input values are called the sets of input value. They are called the domain. Usually, for easy ability, you can just say the values of the left to right, left to right on a plane. The values on the left to right on the plane. Usually, they are the x value, right? The up and down values, up and down like this, are the y values. The up and down values are the y values. These are called the y values. Why these are called the x values? So the left to right are the domains. The domains are the left to right on a plane, okay? While the range are the y values, which are called the up and down values. So the sets of input values to a function is called the domain of the function. The sets of input value. Remember, the x value are always the input value. While the y value or the f of x value are called the output value. Remember the f of x. Remember I started by saying f of x means equal to y. F of x is equal to y. It's same thing. So this is the input. These are input. The x values are input and these are output values. So if you have 2 and then as input and then you have 4 here and you have 3 here, you have 6 here. Okay. So you can tell the relationship. If you have 1 here, you have 2 here. You can tell the relationship that this is a linear relationship and this is one-to-one type of function. Okay. Now let's take a look at this. It said the graph, the function f is defined by f of s equals to x minus 1 raised to power 2, everything raised to power 2 plus 4. This is the quadratic function that's shown in completed square form. Shown in a completed square form. Okay, for those of you, they've given you domain. The domain values are from where is 1. 1 plus 1, we get 2. 2 squared is 4. 4 plus 4, we get 8 here. Okay, if our domain is 4, it's 13. So we get 13 here, and so on and so forth. This type of graph, okay? 0 to 5, look at the plotting. 0 on the x-axis, you trace to 5. That's how you got this plot here. Okay, 1 to 4, although there was 0, we get a range of 5. So this becomes our, was it 5? Yeah, this becomes our range. Is that okay? This becomes our range. Okay, now let's take a look at furthermore, doing it explicitly. Now it says, so the minimum f of x is x minus 1 squared plus 4, right? And we have the minimum point at 1, 1. Where's the minimum point? You know, minimum point is the lowest point on the curve, where the point of reflection starts to take place. Okay, the curve, the place where the curve will take place. So this is the minimum point. So when x is 0, we got y to be 5, right? When x is 0, when we substitute, we get y to be 5. And when x is 5, we got y to be 20. We got y to be 20. So, but because here is the minimum point, so we range it from f of x lesser than or equal to 20 and greater than or equal to 1. Okay? So that is for this one. So for today, we're taking a look at 1.1, 1.2, and probably 1.3, which is the composite function. So this one, you try the exercise, you try to plot, or you try to answer the question based on the what is told to us. They've given us some domain. You are asked to find the range. So you just substitute your domain into the function, you get your range. Is that okay? F of x. Let's say I have another easier way is to place of x. In place of x, we give us what? 13. Right? So g of 3 gives us 13. We get 13. Now, because it's a composite function, this is not the final answer. Remember, they say we should find fg of 3. We've only calculated, you know, you start from the right to the left. Okay? We start from the right to the left. We've only calculated the g of, so it's going to be 4 times 13. 4 times 13. First of all, 4 times 3, we get 12. 4 times 3, we get 12, right? Carry 1. 4 times gives us 55. Okay, so here is another problem. You have g of x equals to 2x squared. We're going to substitute inside h of s. Now, what's our h of s? Let's write it out. 4 minus 3 into, in place of x, instead of writing, and then you equate to negative 4. X will be equal to negative positive 2. Let's assume here is your 2. And here is your negative 2. Here is your negative 2. Here is your negative 2. Negative 2. So you're going to have a function like this. Is that okay? Okay, so with this, we come to the end of our today's class. Thank you for joining us.